Scoping a SOC 2 engagement begins with a deliberate understanding of its drivers and constraints. Every organization must start by aligning the SOC 2 scope with its business objectives and customer commitments. If your goal is to reassure enterprise buyers or demonstrate regulatory compliance, then your scope must include the systems and services that support those promises. Regulations and contracts often shape the edges of what must be included, introducing explicit requirements such as data residency or encryption coverage. Internal factors like risk appetite also influence how broad or narrow the scope should be. Conservative organizations may include more systems for stronger assurance, while startups might focus narrowly on core services to conserve resources. Ultimately, the scoping process balances ambition against practicality, ensuring that what is audited can be evidenced confidently within available time, personnel, and budget. A well-constructed service catalog alignment prevents confusion later in the audit process. Each product, feature, or API that interacts with customer data should be mapped directly to the SOC 2 scope. Supporting internal platforms like internal APIs, configuration services, or authentication gateways must also be captured since they underpin delivery. Dependencies and integration points reveal how data and control responsibilities flow through the ecosystem. Assigning clear ownership to each service ensures accountability for evidence collection and remediation when issues arise. In practice, this catalog becomes both a living reference for the audit and a governance artifact for the business, ensuring that every scoped system has a responsible owner who understands its operational and security obligations. Geographic regions introduce an additional dimension of complexity to scoping. Hosting regions determine where data physically resides and which jurisdictional rules apply. For global services, this includes understanding cross-border data transfers and how legal frameworks like GDPR or regional privacy laws affect processing. Technical considerations such as latency, failover design, and disaster recovery locations influence availability controls and evidence expectations. Some customers may require regional segregation of data for compliance reasons, demanding configuration of routing or tenancy models specific to geography. Properly documenting these regional distinctions ensures that both the auditor and your customers understand how resilience and compliance coexist across your global footprint. Understanding customer data flows provides the backbone for risk assessment and evidence planning. Data ingress points mark where customer information enters your system, whether through APIs, uploads, or integrations. Once inside, data may be enriched, transformed, or stored in multiple stages, often passing through temporary buffers or third-party services. Each of these transitions introduces control touchpoints. Data retention schedules, archival mechanisms, and deletion processes demonstrate maturity in lifecycle management. Mapping these flows ensures that privacy, confidentiality, and processing integrity controls align with actual data movement, not just theoretical architecture diagrams. Well-documented data flow diagrams often become central evidence in both the audit and internal security governance. Identity and access surfaces define who and what can interact with scoped systems. Workforce identities, including developers, administrators, and support staff, require rigorous access reviews and least privilege enforcement. Service accounts and automation secrets must be managed securely to prevent exposure during builds or deployments. Customer identities, particularly in SaaS environments, introduce another access plane governed by authentication, authorization, and often federation mechanisms. Controls preventing cross-tenant access are among the most scrutinized, ensuring that users from one organization cannot inadvertently see another's data. By understanding every identity type and its potential reach, the organization can strengthen both its access model and its confidence during the audit. Most organizations rely on a network of subservice organizations, vendors or partners that perform key operational roles. These might include data centers, payment processors, or monitoring platforms. The scope must clearly identify which subservice organizations are relevant to system commitments, and whether they are treated under an inclusive or carve-out approach. Inclusive means their controls are tested within your report. Carve-out means they are excluded but disclosed, requiring you to obtain their own SOC reports or equivalent evidence. Maintaining a monitoring plan, reviewing vendor assurance, and documenting evidence requests ensure these dependencies do not become blind spots. Subservice transparency is often one of the first sections auditors and customers scrutinize. The scope also extends to tooling and pipelines, which form the operational fabric supporting development and delivery. Continuous integration and continuous deployment (CI/CD) platforms, artifact repositories, and infrastructure as code layers all influence how secure and repeatable the environment is. Observability tools such as logging, monitoring, and alerting systems ensure ongoing control visibility, while collaboration tools like ticketing systems or wikis store critical evidence of review and approval. These supporting systems may not face customers directly, but their reliability and integrity directly affect SOC 2 outcomes. Including them in the boundary ensures that controls around change management, access, and incident response are fully represented and auditable. Defining interfaces and integrations helps uncover hidden exposures and control dependencies. Inbound and outbound APIs, message queues, and event buses create pathways for data and commands to flow across systems. Each must be documented, with special attention to authentication mechanisms, rate limits, and abuse prevention. Batch processing or file transfer systems often operate outside of real-time visibility, but remain vital to processing integrity. Knowing where these interfaces exist and how they are secured allows the organization to demonstrate not only operational soundness, but also awareness of potential attack vectors. Detailed documentation of integrations simplifies the auditor's testing plan and strengthens customer confidence in system transparency. Finally, scoping intersects directly with data classification, clarifying which categories of information are handled by in-scope systems. Mapping these data types, such as public, internal, confidential, or restricted, to confidentiality and encryption requirements ensures proportional protection. Encryption policies should specify algorithms, key lengths, and storage states covered for each class. Where customers have configuration options, such as bring your own key encryption or access control tuning, those capabilities should be explicitly described. This mapping is not only helpful for auditors, but also crucial for internal security teams to prioritize controls according to data sensitivity, ensuring no class of data is left underprotected. Despite careful planning, scoping pitfalls can derail even mature organizations. An overbroad scope can stretch resources thin, leading to shallow evidence collection and weak assurance depth. Underscoping, on the other hand, may exclude critical dependencies, creating audit gaps that undermine credibility. Ambiguous boundaries, where responsibilities between internal teams or between provider and customer are unclear, cause confusion during testing. Perhaps most dangerous is shadow IT, untracked systems or integrations that process sensitive data outside official oversight. Effective scoping requires governance discipline, regularly updated inventories, cross-team communication, and independent validation that the boundary reflects operational reality, not wishful thinking. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Once the scope has been defined, the next step is applying risk-based prioritization to determine where to focus the most effort. Not all systems and controls carry equal importance, so ranking components by both impact and likelihood helps direct testing where it matters most. High-risk data flows, such as those involving customer credentials, payment information, or production access, deserve deeper scrutiny. Similarly, controls tied to incident response, encryption, and identity management often receive higher sampling volumes because their failure would cause significant harm. Documenting the rationale for these choices shows auditors that the organization takes a thoughtful, methodical approach to risk, not a blanket, one-size-fits-all strategy. This risk-based mindset ensures limited resources yield maximum assurance value. Auditors expect proof of isolation in multi-tenant and complex architectures. This means showing how customers' data and workloads are separated through a combination of network segmentation, access control, and infrastructure design. Artifacts such as firewall configurations, VLAN assignments, and cloud network policies serve as concrete evidence. Logs showing tenant-aware access events confirm that no cross-tenant exposure has occurred. Compute isolation, such as container sandboxing or hypervisor separation, provides additional defense in depth. Some organizations validate these boundaries through periodic penetration testing focused specifically on isolation controls. Demonstrating these results not only satisfies the audit requirement, but reinforces customer trust that their data resides within a rigorously enforced digital perimeter. Resilience by region reflects an organization's commitment to continuity in the face of disruption. Geographic redundancy, whether active-active or active-passive, ensures services remain available even if one region fails. Recovery time objectives, RTO, and recovery point objectives define the expected speed and completeness of recovery efforts. Documented failover runbooks and automated triggers show that disaster recovery processes are tested, not theoretical. Regularly scheduled recovery drills, complete with metrics on restoration time and data integrity, provide tangible proof of resilience. Customers and auditors alike look for evidence that regional architecture isn't just scalable, but also survivable, protecting availability commitments under the most adverse conditions. Privacy overlays ensure that SOC 2 scoping fully integrates obligations related to personal information. This begins with maintaining an up-to-date inventory of personal data and understanding its processing purposes. Each purpose must map to a lawful basis, such as consent, contract performance, or legitimate interest. Evidence should demonstrate that data subject rights, like access, correction, or deletion, can be executed within the scoped systems. For multinational services, the organization must document cross-border data transfer mechanisms, whether through standard contractual clauses, data localization, or privacy frameworks like the EU-US Data Privacy Framework. Integrating these privacy elements into the scope highlights the organization's commitment to ethical data stewardship and compliance. Defining operational ownership within the scope ensures that every control has a clear, accountable party. Key scoped areas, such as infrastructure, identity management, or application security, should each have designated control owners who understand their responsibilities. Escalation paths define who acts when incidents or control failures occur, preventing confusion during real-time events. In globally distributed teams, these handoffs may follow the sun, ensuring coverage across time zones. Training and enablement help owners maintain awareness of SOC 2 expectations, reducing errors from misinterpretation. Clear ownership doesn't just satisfy auditors, it embeds accountability into the organizational culture, making assurance a shared operational value. Strong evidence planning transforms scoping from theory into practical audit readiness. Each component in scope should have a defined list of expected artifacts, system configurations, logs, screenshots, or tickets, aligned with relevant controls. Identifying source systems early avoids last-minute scrambling when auditors request samples. Defining sample populations and selection boundaries ensures fairness and repeatability in testing. Chain of custody procedures document where evidence is stored, who handled it, and how integrity is maintained. A disciplined evidence plan not only supports the audit, but creates a repeatable, efficient process that can be reused in subsequent cycles, minimizing disruption to operations. SOC 2 scoping has direct customer-facing implications that go beyond internal audit mechanics. The way services are described in public documentation must align with what is actually in scope. If certain regions, data types, or subservice providers are excluded, those limitations should be clearly communicated in service descriptions and terms of use. Complementary user entity controls, QSECs, must also be explained. Customers need to understand their own responsibilities for shared security outcomes. Creating FAQs, or trust portal summaries that address common scoping questions, helps reduce confusion and builds transparency. Customers appreciate honesty about boundaries more than vague promises of total coverage. Change management alignment ensures that scope decisions remain valid as systems evolve. Every major architectural or process change should undergo a risk assessment to determine whether it impacts the SOC2 boundary. Changes involving new technologies, data flows, or vendors must be reviewed and approved by accountable owners, with documentation captured for traceability. Post-change validation testing, that new controls operate as intended, closes the loop. When managed well, change control becomes a living guardrail that keeps the scope relevant and defensible, protecting the integrity of the attestation even as innovation continues. A disciplined program includes continuous scoping review, recognizing that systems and risks evolve throughout the year. Quarterly reassessments help detect drift as new components are added or retired. New vendors, environments, or customer features triggers scoping updates and contractual amendments when necessary. Incident learnings often reveal hidden dependencies or untracked systems that must be brought into scope. Treating scoping as a dynamic process rather than a one-time task keeps the organization aligned with its actual operational reality. This adaptability is a hallmark of mature SOC 2 governance and avoids embarrassing surprises at renewal time. Monitoring metrics and thresholds provides insight into the health of the scoped environment. Measuring the percentage of components successfully evidenced shows audit coverage completeness. Tracking time to evidence requests highlights operational efficiency and potential bottlenecks. Defect rates, issues found during testing, indicate control robustness, while remediation lead time reveals how quickly teams can correct deficiencies. These metrics allow leadership to assess program performance objectively and set improvement goals. Over time, data-driven insights transform compliance management from reactive reporting into continuous assurance. The SOC 2 journey culminates in a formal scope sign-off process. This is a collaborative review across engineering, compliance, legal, and leadership teams to confirm that the documented scope matches business intent and operational reality. Leadership approval demonstrates organizational alignment and accountability. Engaging the auditor for a pre-alignment check before fieldwork begins helps prevent misunderstandings about inclusion or exclusion criteria. Once finalized, the scope should be published in internal documentation portals, ensuring everyone, from system owners to executives, understands what's in play. This transparency strengthens both the audit and the organization's internal governance posture. In conclusion, scoping defines the architecture of trust upon which the entire SOC 2 program is built. It determines which services, regions, and tenants are assessed, and it anchors every piece of evidence that follows. Effective scoping balances ambition with feasibility, ensuring the organization can confidently demonstrate control over what truly matters. By embedding risk-based prioritization, isolation proofs, privacy overlays, and continuous review, companies create a living scope that evolves with their business. A well-documented boundary, clear ownership, and ongoing validation transform scoping from a compliance exercise into a cornerstone of reliable, transparent operations ready for the next phase, aligning those scoped elements to the trust services criteria themselves.